Space is a very challenging environment to work in, and I think it's something that is easy to forget. So we see our very professional astronauts from countries around the world launching and going and living on the International Space Station, doing their scientific and their engineering work and really pushing the frontiers of human knowledge. And of course, they're incredibly well trained. They're very professional about the way they go about their business. So I think it's very easy for us to forget on Earth that actually it's such a challenging and dangerous environment, and it's one that should be treated with immense respect. And obviously all of the engineering teams that support those astronauts also have a huge amount of expertise. So I have a lot of respect for the teams that work around that. I think there are other hazards, for example, human-made space debris. There was a piece, literally probably about a centimetre in size, so not huge chunks of debris. It's the small particles that are left over after collision after collision. They don't go anywhere, they stay in orbit around the Earth. One of those actually punctured a hole in part of the International Space Station. And so that's one of those hazards that the astronauts are very mindful when they're up there, but they don't actually have any control over. And so I think that those sorts of bigger challenges for that space environment is something that we can all work on as scientists and engineers, and also policymakers internationally, to try to keep our astronauts safe when they travel up off the Earth. So I think humans have always pushed the frontiers, whether that's through exploration, whether that's through conflict. And I think it's when we look up at the sky and we look at the universe, that's one thing that unifies us as a species. And I think what, for me, in my personal opinion, is really important is that we see the universe as something that is for all of our species, so it shouldn't be territorialized, if you like. And I think that the challenges that we have to overcome in order to go out and explore and discover the universe is something that transcends national boundaries, and it's a very unifying, very positive endeavor to work together to try to solve those engineering challenges, to go out to new frontiers. So I think it's actually a very positive thing to do, particularly at times of conflict. So in terms of the balance between thinking big and thinking practically, I would say both, actually, because it's when you think big that you then discover the practicalities, and then you start to see those benefits come into other areas of life. I think a good example of this is around, for example, quantum optics. And so this came from radio astronomy, where radio astronomers were building bigger and bigger and bigger dishes. The question they were trying to solve, well, what was the nature of some exotic objects in the universe, which we now call quasars, and we know these are giant supermassive black holes that are trying to consume material around them. But they realized that they were hitting a physical limit by making their dishes larger and larger. And in fact, it was the conceptualization of interferometry, where you connect two smaller dishes and you make a network of dishes. The size of the network is then equivalent to the size of the telescope that you want to build. And it was actually the debate with physicists as to whether that was important in the optical part of the spectrum that then drove the development of the modern field of quantum optics. It's the Hanbury-Brown Twiss optical interferometer. And that's opened up a whole new area of physics and potentially innovation and commercial drivers. So I think it's the big questions. No one would ever have thought that, quantum technology would have come out of a quest to understand objects that turned out to be supermassive black holes at the edge of the distant universe. So I think in terms of the societal payoff from pushing the frontiers of knowledge, for me, I think there's a pipeline. And again, one has to think about timescales. So there may be a very big question that we want to solve, and it may be 100, 150, 200 years before we get the answer to that. But the journey that we take along that path to answer those questions is really what then gives us the societal benefit. So one good example is Einstein's general theory of relativity, which when he first published his seminal paper back in 1915, was a great piece of mathematics, wonderful innovative thinking, but one could be excused for thinking it was an esoteric piece of theoretical physics that would lie in the literature. Now, 100 years later, all of our global satellite positioning systems, our satellite navigation, our telecommunications could not operate in the way that they do without our understanding of general relativity and making sure that the maths sits in our satellites. And so Einstein did not sit down to invent satellite navigation, but without his discoveries we wouldn't have those benefits now. So I think the question of resource allocation between fundamental curiosity-driven research and commercial exploitation is one for each country to decide for itself, and also to think about its partnerships with other countries. So it may be that one country is particularly strong on commercial innovation, another country might be investing in fundamental research. And I think for me the question is how those nations can then share the different skills that they have. The big facilities that we're building now to do fundamental science must transcend individual nations. They're far too big and challenging for one country to do alone. But again, if one works across different nations, pooling resources and pooling expertise, then the commercial benefits will also be shared, and it brings our countries together in a way that also helps us to address conflict, because scientists and engineers don't work on a nationalistic basis. We certainly compete. We like to compete to be the best and be the frontier, but that competition is not based on a nationalistic perspective. So there is a whole host of space missions that excite me. Currently, I think I've been really excited by the solar system missions. The work that I do in my research, the objects are so far away that actually I haven't done research in the solar system, but I think the new things that we're discovering, landing on comets, sending rovers across Mars, actually discovering the formation and the evolution of our solar system and revolutionizing our understanding of where our planet Earth came from. For me personally, I think they're very exciting. I think in the future, measuring ripples in space-time with the LISA interferometer, which will be a space-based fleet of satellites working together. That, for me, in my personal research is really very, very exciting. I think the test technology that has already been flown has shown that that kind of mission will be utterly mind-blowing, I think, in terms of the data quality. And then I think in terms of other kinds of missions, there's a whole host of different test beds being developed, I think, to develop our capability for human exploration. Again, those go really beyond our capabilities at the moment, but to be able to do that and to build on the legacy of things like the International Space Station is just, incredibly pioneering and exciting.